Good afternoon, everyone.
Hello, good afternoon.
Hello.
Good to be back after such a long time. Apologies to everyone for the interruption, but it was for reasons beyond my ability to control.
Hello, good morning, everyone.
Hello.
Good morning, good afternoon.
I guess it's afternoon for most of us, right? And it's almost late evening for Xuan.
Good afternoon, everyone.
Connecting from Beijing. So thank you.
Hi, Carlo.
Hi, Xuan. Thank you, everyone, for resuming this initiative. I apologize for having interrupted for a while. In the meantime, I hope that you had an opportunity to look at the recording of the four previous lessons, and then so now you may be even more expert than I am, or you may have so many questions that you may want to ask. But I would like to take an opportunity now to proceed with a very actual, very urgent and important need, which has emerged in these past few weeks. So we are now proposing and using the FIES questionnaire to also assess the differential impact that the COVID epidemic might have on food insecurity. So what I would like to do today is to go over an example of analysis of data that has been collected using an amended, a special extended questionnaire, which has the objective to be able to monitor food insecurity, but also to determine what part of the experienced food insecurity of people could be attributed to the COVID situation. And what I plan to do then is to go through a very simple R script that will illustrate how the analysis can be conducted. So let me start by sharing my screen. And the first thing I wanted to show you is the actual questionnaire. Just a second. Can you, some of you, please confirm if you can see a window with
Yes.
a PDF?
Yes.
Yes, Carlo.
Okay, thank you. So I hope this is clear to everyone. Should I enlarge it or can you read it well? So this is
Perfect.
an emergency food and agricultural monitoring initiative that was conducted in Malawi with support from FAO. And as you will see, these include the typical food insecurity experience scale model, though I will highlight, is referent to the last 30 days. So this is a way to measure the recent prevalence of food insecurity. But then, this is the innovation. If responded said yes to the question. Then we follow up asking whether in the respondent opinion, this experience occurred because of the COVID-19 crisis, giving again the option to say, to confirm the yes or say no, or to say I don't know or to refuse. And so this is true for all 8 questions. And now this specific module has also an additional extension, which only applies to question number 7 and question number 8, which if people says yes to the question, then there is also a question about the frequency. So whether that occurred rarely, sometimes, or often. Today I will not comment on this extension with the frequency, but I will comment on the analysis of the potential COVID impact. So now let me go to the R screen, and once again, can I ask you to confirm if you can see the screen well enough, or whether should I enlarge the text?
I think it is fine.
Thank you, Anna. So let's start going, and I will be rather quick, but if there is something that is absolutely unclear, please interrupt me so that I can clarify. Now I'll keep my chat window on the other screen. So even if you cannot interrupt by speaking, you can type your questions. So here in this first line, I just set my working directory that points to the place where I keep the data. And then I load the data that was collected using the questionnaire I just showed you. As you can see, this file contains almost 5,000 records. There is a total of 34 variables. Variables include the region, the district. I have no idea what the EPA stands for. It's probably the enumerator or unit, I don't know. Somebody from Malawi might recognize whether these are regions or enumeration area, I don't know. Then there is the sex of the data collector, what the data collection date was, and you can see this data it's very fresh. It was collected in between the end of May and the beginning of June. Then we have the respondent of the sex of the respondent, the location, because I understand these were collected using mobile handheld devices. And then here is the questions. So question number 1 is actually the worry question, but it has been labeled no food, because part of the question is you were worried there were no food. And then you see that in the question 1 and the question 1A, somebody is attending this meeting from the street. Sorry, can you mute the microphone, whoever is in the middle of a crossing in the street with car honking? Thank you. Let me increase the font a bit. Adiba, is it better now? So here we see an example of the structure of the data. Only when Q1 has been answered yes, there is an answer to the follow-up. And in particular, those first 5 cases said, yes, I have been worried about food, but it was not because of the COVID. And the same question number 2, there is a follow-up only when the answer is yes, and so on. In some cases, you see that the person was not able to say yes or no, and they say, I don't know if it was because of the COVID or not. And this is important, might reveal some hesitation or inability of respondent to relate to the COVID epidemic. Then, when we reach question 7 and question 8, we have a third column that when the answer is to question 7 is yes, can be rarely, sometimes, or often, or also don't know. And the same is for question number 8. Again, the follow-up to question number 8 will be there only if the answer is yes. And if the answer is yes, the frequency can be rarely, sometimes, or often. And then, was it because of the COVID? The answer can be yes or no. Then finally, we have some sampling weights that I won't use in this analysis for simplicity, but it's good to know that they are there. And also, you may have noticed that some cells imported from the CSV file are completely empty, because this would be the true non-applicable question, because given the answer was no or refused, there is no follow-up. So the first step in the data analysis is to recode the empty cell as actually not available, and R allows to do it very easily on the entire data set. So with the line number 4, every time I have an empty cell, this cell will be filled with the symbol for not available. Now, if we go back to the data, you see that not available appears. Then, just to avoid confusion, the frequency response, I am changing the name so that they do not have this Q7 and Q8. So I will rename the columns Q7A it nothing and Q8A nothing hidden with the names that refer to frequency. Again, once you do these changes, they get immediately reflected in the data set. So now that you see that this column and this column have a new name that refers to the frequency. Now, as you remember from the questionnaire, we ask first, were you worried about food during the past 30 days? And if the answer is no, the follow-up question is not asked. However, logic suggests that if I were to ask directly, were you worried about food because of lack of money or other resource, particularly because of the COVID epidemic, the answer should also be no. So we are filling the obvious response that whenever Q1, the condition is if the response to Q1 is no, also the response to Q1A should be no. And we do the same for Q1, Q2, Q3, Q4, Q5, Q6, Q7, and Q8. So these lines from line number 8 to line number 15 are needed to complete the answers in a logic way, that if the answer to the first question is no, also the answer to the follow-up, was it because of COVID, is no. Why is this important? Because in this way, we can use this data by simulating two different scales. It would be like having conducted two surveys, either asking only the FIES question, irrespective of whether was it the COVID, or asking only the COVID specific question. And in this way, we have a complete set of data. Let me stop here and ask if everything is clear thus far. Okay, nobody is reacting, so I assume it is clear. Again, we want to make sure that we have the possibility of conducting two assessments. One is, what is the overall prevalence of food insecurity in the last 30 days, irrespective of whether people attribute this to COVID or not. And the second addition is, which part of this food insecurity can be attributed to COVID? And therefore, there is a question with an additional qualifier. Was it because of COVID? And just to give a look at the now consistency of these responses, I will simply tabulate responses to the two related questions. So in this table, you see the combination of responses to Q1 and to Q1A. So in this data set, there are 985 people who said yes to Q1 and 1,840 people who said no to Q1. And of course, there is, sorry, I was mistaken, because the number of people who said no is the sum of, sorry, let me put it again. There is a total of 985 plus 888. So it's about 2,800 people that says yes to question one, but about 2/3 of the total, 888, said no to the question, was it because of COVID? So the majority of the people said yes to question number one, but only half of them who said yes, sorry, 2/3 of those who said yes didn't attribute to COVID. And in addition, there are a few responses of people that either say, I don't know, or refuse to answer the COVID specific question. Again, is this table clear? And apologize for my small confusion. So here we have the cross tabulation of answers to the two questions. And there is embedded consistency in the fact that if the answer is no to Q1, it can only be no to Q1A. Because actually this has been created by logic, by construction. We can do the same for all questions. And you will see that overall, the number of people who do not link it to COVID is almost always higher than the number of people who said yes and link it to COVID. So overall, we would expect that the prevalence of food insecurity that can be attributed to COVID, it's only a fraction, a relatively small fraction of the overall food security. Now, I don't have any specific detailed information on what was the evolution of the pandemic in Malawi, what is the situation in June. So I cannot comment on whether this is because people is misinformed about COVID or because actually the full extent of the COVID epidemic has not been felt yet in a country like Malawi. Everything clear so far? So now that we have fixed the data table so that we have all the information, we can run the rush analysis. So remember, the rush analysis requires that we codify the data as numeric values with 1 if the answer is yes and 0 if the answer is no. And all other answers like don't know or refused must be treated as not available. So line 26 also make this final change, transforming the don't know and the refused into not available. Now I will need to create the numeric table starting from this data. To do this, I just create 2 temporary data frames which are just capturing the relevant questions, Q1 to Q8, and then Q1A, Q2A, Q3A, Q4A, Q5A, Q6A, Q7B, and Q8B. These would be subsets. This is the subset command of the data, focusing only on the 8th variable that forms the FIES. Both of them are 4,848 lines with 8 variables. So now I initialize 2 empty numeric matrices filled with not available with the same number of rows and columns that I need. And now I fill these 2 matrices with 1 and zeros. 1 when the original data is yes, and 0 when the original data is no. Is it clear so far? Don't be shy to ask if it's not clear. But I think we haven't done anything sophisticated. So far it's just making sure that we have the data in the proper format. And now, for convenience, I transform these matrices into data frames, and I give them the typical names that we use for the FIES. So now I can look at the tables, FIES or FIES COVID, and you will notice that they have the structure that we normally need to do the rush analysis. Remember, these are very similar to the Excel table that I showed you in one of the first lectures. So we are ready to run the analysis. And as I said, for now, I'm neglecting to use the sampling weights because that is not the purpose of this presentation of this lecture. So now I estimate the rush model. I'm using the rm.w command from the rm weights package. And I do this for the FIES matrix, which is the one that contains the data irrespective of whether the respondent attributed to COVID or not. The most important results to look at immediately is the severity level and the infit statistics. And we notice that there is one item number 2 or healthy, that has an infit that is greater than 1.3. Because of this, we must exclude this item from the analysis and therefore re-estimate the model, excluding that variable. So in line number 45, I'm estimating the rush model using the FIES without the second column. Few seconds, and then here is now the results. The other 7 items have all very good infit, between always less than 1.2. In terms of severity level, they more or less confirm that few foods, worried, skipped, ate less have lower severity, run out, hungry, and whole day have higher severity, and whole day is particularly more severe than all the rest. You may recall that one device that is used also to check that there is no residual problem once estimated rush model is to look at the percentage of the variance that is explained by principal components derived from the matrix of residuals. And here you see this is very close to a straight line. There are no sudden jump following the first or the second component, which confirms that this data set is a high quality data set interpreted as a measurement scale for a single dimension latent trait. Another parameter that is useful to establish the quality of the data is the reliability parameter. And they say that almost 70%, 66% of the variability in the data can actually attribute to the variability in the latent trait that we want to measure. So, first conclusion, the FIES dataset, which is the responses to the question asking independently of the COVID, form a good scale with 7 items. There is some issue with the healthy items that might deserve some further explanation. But for now, we can continue with a scale of 7 items. Let me pause a second. Again, is there any questions, any doubts, anything that is unclear? Okay, no one reacts.
Yeah, Carlo, can I?
Please, Firas, thank you.
Just looking at the size of the two data set, FIES and FIES COVID, they have the same size after splitting. So I don't know if this is right because they have 4,848. I suppose should be split. The sum of both should be the total number.
No, Firas.
Okay.
No, because these, the respondents are exactly the same. Each respondent have been asked the question, were you worried about food? Then, if they say yes, was it because of COVID? But they are asked both questions. Even if they say no, and we don't explicitly ask the second question, we assume, because of logic, that the only consistent answer was no, because if I said I've not been worried about food, it cannot be that I was worried about food because of the COVID. So the first question embeds partly the response to the second. So it's only an economy of data collection that allows duplicating the answer, but this is exactly the same sample for both scales, and it must be like that. So our sample is 4,848. Now there might be slightly more missing observation because some of the people who said yes to the first question, when asked the second question, said, I don't know, or refused. Remember, there were 53, 72, 67, but these are very small number compared to the sample size. But that's the only difference between the FIES and the FIES COVID. Does anyone else have the, yes, Ibrahima, I see you raised your hand.
Yes, Carlo, I want you to know here with this example, we have just one variable we need to be removed from the model.
Yeah.
But what should happen if we had, for example, 2 or 3 variables?
No.
I mean, is there a minimum number of variables we need to keep in our model?
Very good questions. So what we need to do, as I said, as you saw, I removed one variable and I run the model again. In case running the model again, there is another variable that shows a high fit, I have to remove it, that one too. Our suggestion is that you should have at least 5 questions to claim that you have a sufficiently robust measurement scale. So if you have to remove more than 3 questions, I would conclude that the FIES did not work in that condition application situation. So the minimum number of questions is 5. But this is just an arbitrary threshold based on experience. There is no absolute threshold. I mean, if you are in an emergency and you need to make an assessment, you can also proceed with 4 questions, but be aware that the fewer questions you have, the larger would be the measurement error, the uncertainty around the measures that you obtain. Okay, any other questions or doubts?
Carlo?
Anna?
No, what it is not clear to me is how to interpret the graph, because this big jump on the last, how can I say that this is not a problem?
No, the big jump on the last dimension is not a problem. It only reveals that actually there is a quite high correlation among the residuals overall, so that the last principal component doesn't explain anything. Everything is explained by the first 6. But this is not a big problem, because means that the problem would be if the first component dominates, because it would mean that there would be a clear dimension that is not random, that is captured by this data, which is not the food insecurity severity. So to interpret this graph, you have to think, we have filtered from the data all the information that refer to food insecurity severity. Is there something else in this data? Something that guide the way in which people respond to this question? And if that is the case, it will appear as a dominant dimension in the residuals. Can be, there are 2 additional dimensions, so will be the first and the second and then a jump. But once you have reached the first 6 dimensions, you have essentially already filtered the information so much that there is nothing else to be explained. So the jump after the 4th, 5th, 6th dimension, it's irrelevant.
Oh, okay, thank you very much.
This graph needs to be looked at whether it's an L-shaped. If this graph looks like an L, with the first component that explains a lot, and then a jump, then it's problematic. And if you want to deepen this analysis, you should refer to the principal component analysis and how to interpret principal component. If you are interested, there is a very good text by Jolliffe on principal component that is a very clear explanation of what principal component analysis does. Okay, let me continue. So we do now the same analysis using the FIES COVID dataset, which is the dataset that includes responses only if yes or no, and yes because of COVID. So it's either no, I have not made that experience, or yes, I made that experience, but it was because of COVID. So as we saw already in the tabulation, this is a there is a lower number of yes answers. And therefore, the prevalence by construction will be lower than the total prevalence. But that's exactly the point of the analysis. We want to identify how much of the existing food insecurity is attributable to COVID. So let's run line 52. Let's look at the results. And now you notice a difference that the healthy item seems okay, but the worried and the whole day are not, even though the whole day is almost there. So, and this is also an example for Ibrahima, the way to go is, okay, let's start with the most problematic item, item number 1. Let's remove it and run the analysis again. So you see now I'm estimating the Rush model on the FIES COVID matrix, excluding item number 1. In a few seconds, we will have the results. Let's look at them. And you see now what happened. Even the whole day is fine. So having removed the worried item, make the remainder of the scale sufficiently consistent to be used. And again, roughly the ranking of the severity is the same, even though you may notice that the numbers are much closer to each other. Here whole day would go to 1.99. Here all day goes only to 1.36. But you should also remember that you cannot directly compare the results of two different assessments, even if they are done exactly on the same population, and in this case, exactly on the same sample. And the reason is because this is an arbitrary scale. It's not yet calibrated against a reference scale. But nevertheless, let's complete the analysis. Here, the scree plot is a little bit less ideal. So there is a gradual reduction from the first to the second and from the second to the third. But it's still not an L-shaped. So even though the quality is overall less strong, which is understandable because here you have some uncertainty also on the people having to say, was it because of COVID? That's not an easy question to answer. So there might be some additional noise in the answer, but it's still such that we do not exclude. We can perform the analysis. The reliability is slightly lower, it's less than 65%, but it's also still acceptable. So we have now two results, two different scales. We want to compare them because before making the assessment now of the prevalence, we need to make sure that whatever threshold we use is the same threshold of severity. So now we are interested in doing a comparison between two assessments. And the first thing is, are we speaking of the same scale or not? And now I want to show you the comparison of the two scales. Now remember that in the first case, I have worried, few food, skipped, ate less, run out, hungry, and whole day. In the second case, I don't have worried, but I have healthy. And then I have the same items. So the common items between these two scales are only from the second to the seventh. So before doing the comparison, I want to exclude the first one. That's why I am plotting the result excluding the first item in both. And now let's complete it with some text. And you see that these 7 items are aligned more or less on a straight line with an exception. The hungry item seems to be slightly different. Again, it's a valid item. It works well in both scales, but it reveals a different severity. So we need to take that into consideration when we do the equating. But what I wanted to show you now, remember we noticed before, look at the scale here. Goes from -1 to 2, whereas in this goes only from -0.5 to 1.5 more or less. So these two sets of parameters are not on the same scale. That's why we need to equate them before calculating the prevalence, because otherwise it would be very difficult to impose the same threshold in the two assessments. So to do this, I need to identify the set of common items for calibration. And my proposal is that this set comprises few food, ate less, skipped, run out, and whole day, and does not include hungry. And then the equating is done by stretching and shifting one of the scale so that the mean and the standard deviation of the common item is the same into the original scale and the adjusted scale. So I calculate this mean and standard deviation, and I decide to adjust the COVID scale. So I want to bring this vertical dimension on the same scale of the horizontal dimension. And this is line 72, is how we do this transformation. We take the original scale, shift it so that it is centered on the mean of the common items, rescale it so that it has the same standard deviation of the first scale, and then centered on the mean of the common item of the reference scale. So I'm using the FIES as the reference, and I'm adjusting the COVID to the FIES. And I need to adjust all parameters, the item parameter, the respondent parameter, and also the standard errors of the respondent parameter. And the standard errors don't have a mean, they're just around 0, the mean is 0, so we don't need to do the shifting, it's only a rescaling. Now, I recognize that this is probably the most sophisticated aspect in this analysis. So you will probably need to think carefully about this. But let me show what the result is. If now plot the original result for the FIES scale against the adjusted result, I have what sorry. I didn't run line 66 to 75. So if I plot now the adjusted scale, is essentially the same graph. I'm only plotting the common items. And then I add the one item that is not common. But now this graph and the previous graph are exactly the same, with the only difference that this axis reflects the same scale. So that if I now draw a 45-degree line, you can see how close the two scales are. Then remember that we have also one item that we excluded, not because it was not a productive item, but it was unique in each application. So we have the worry item that was only used for the COVID, for the FIES scale, and the healthy item that was only used for the COVID scale. And therefore, they will be used, they will contribute to the analysis, but they are not part of the equating. That's why I'm plotting them in different colors. So, to summarize, we now have a scale that is measuring the food insecurity independent of the COVID. A scale that is measuring the food security due to COVID, which has been calibrated to be reflected in the same metric of the first one. And now, if we can set a threshold, we can calculate the prevalence of food insecurity in general or only because of the COVID. Sorry, I just see now one question from Bubadi. The question is, I don't know, you can all read in the chat, the fact that we drop item 2 in normal FIES and we integrate it in the FIES COV estimator. I'm wondering if this does not affect the comparison. And Bubadi, the answer is no, this is not affecting the comparison because item 2, healthy, is only used when we measure the COVID scale. And the same item 1, worry, is only used when we measure the prevalence on the FIES scale. But what is important is that whatever we are measuring is the same thing. That is the beauty of the underlying theory that allows for the possibility that you don't necessarily need to use exactly the same items in two different applications. Just to give an example, imagine that you are a professor and you want to measure the students' competence, and you go into two classes and you give exactly the same questions, or you go in two classes and you give a different combination of questions. The Rush model has been developed to respond to that need. I want to make sure that I am measuring the same thing, even if I don't use exactly the same questions every time. So this is an example of an application that it is possible not to lose the information that is provided by people answering the worried question or by people answering the healthy question when we do the analysis. So again, the answer to your question is no, this is not going to affect the comparison if it's done properly. And to do it properly, we needed to go through this equating process, which I insist is probably the most complex thing to do. But I would suggest that you keep thinking about it, and then next lesson, if you still have doubt, we will go back to this question. So now let me quickly complete the analysis, and then I will need to leave you because it's already almost 3 o'clock. And then we will continue probably next time. Now what I do, I borrow the global reference scale and I do an equating between the global reference scale and this Malawi scale. And I'm using the FIES because that is being used as the reference for this analysis. And just I will go very quickly to show that here there is a relatively good equating that is based on 5 items. Few food, ageless, skipped, run out, and hungry. And notice that neither worried nor healthy, which are the 2 problematic items, are part of this equating set. With this equating, I can use the global reference corresponding to 8 less and to whole day to calculate the probability for each row score and the prevalence, both moderate and severe. So with this data, we find that 63% of the population represented by this sample has been moderately or severely food insecure in the previous 30 days. And a quite high percentage, 42%, have been severely food insecure. So these are quite high numbers. But these are consistent with other assessments that we have from Malawi. Then we do the same thing using the adjusted COVID scale, but the same threshold. So this is important that I'm using the same threshold, otherwise the comparison will not be valid. And here are the results. Of the 63% of people who are moderately or severe food insecure, only 18% are linking this to the COVID. So from this, we might infer that the difference, which is about 45%, would have been the prevalence of food insecurity at moderate or severe level if the COVID had not appeared. Because those 18% would have said no, would not be there, because they are saying yes because of COVID. Similarly, of the 42% were found to be severely food insecure, 13.5% are because of COVID. So COVID does have a significant impact of about 13% additional food insecure at severe level and 18% at moderate or severe level. And with that, I have to close the session, and I will share both the script and the data to allow you to replicate the analysis, but with a very important prayer to all of you: do not further disseminate this data in any way, because, as I said, these are real data coming from an assessment, but for which the report has not been published yet. And we haven't discussed these results yet with the people who collected the data. So please do not further disseminate this data. I will try to anonymize them, but you know that they refer to Malawi and the COVID, but please use it only as an example. So thank you everyone, and we'll see each other again next week. Oh, before I leave, I will need to ask permission of using your recorded video or your questions if I go to disseminating a condensed, edited set of videos derived from this lecture. So if anyone do not agree in that your image, your words might be shown in a video that we will produce as a team, please send me an email and let me know. With that, I thank you everyone, and I see you next week.
Thank you. Bye.
Thank you. Bye-bye. Thank you. Yeah.
Thank you. Bye, colleagues.
Bye. Bye-bye.